Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, I'm Keith Kaplan, a software architect at Microsoft, and I'd like to welcome you to Behind the Code. In this series, we feature Microsoft employees who have achieved great things. Our goal is to reveal what it takes to create great software as we look at the technology and the person behind the code. Tony Williams is a software architect in the Connected Application Framework Group. In his 18 years at Microsoft, Tony has advocated componentized application development. His accomplishments include helping to invent the COM and OLE technologies that allow different pieces of software to communicate and work together. Today, Tony is driving the design of a new component framework which will be used in Office 12. Tony holds a PhD in high-energy physics from Oxford University. Please welcome Tony Williams. We're glad to have you here, Tony. Let's start with something fun. Tell us about a typical day in the life of Tony Williams.
A typical day in the life is kind of a tough call. They're pretty varied. Nowadays, it starts with email, typically at home with my morning coffee. Lately, it's been 2 to 4 hours a day of design meetings with maybe a meeting about 4 or 5 people. I try to get an hour or two thinking, which I think is an important part of the job. And I've been more recently getting some time coding, which is a nice change for me. I haven't done that for a long time. So I'm coding on a prototype and enjoying it just like I used to.
So let's go all the way back to the beginning of your career. Where were you born? Where did you grow up?
My career, wow. I was born in London. I grew up in various parts of England, in Leeds, in Yorkshire, and in Newcastle in the northeast. So those were sort of the formative places that I lived.
What did you study when you were in university?
Well, I did physics for the bachelor's degree and then high-energy physics for PhD.
This is sort of a strange change then. You have this career now in software, yet you started out studying physics. How did that sort of change happen?
Well, any science, even back then, any science involves a lot of computation to actually, analyze data, compare theoretical equations with actual measurements and stuff like that. So, as a physicist, working physicist, you're doing a lot of work with computers, and so that's where I got hooked on programming as an activity. And when the time came to actually get a job that would pay money, what I was facing was, well, I could be a sort of average physicist doing the same sort of things that I'd been doing as a grad student, which entailed spending a lot of time programming things for fun and quite a lot of time programming boring stuff to do with numerical analysis. And so I thought, well, why don't I go do the programming thing for real and get paid for it and do the fun stuff for a living instead of on the side. So that's how I made that decision. I just said, I'm going to go and do software.
So had you used computers at all prior to being at university and doing your physics work there?
I had a tiny bit of exposure as I did an internship in London at the city council the summer before I went to college, and I'd done some work with computers there, but not actually programming.
So here you are now. You're a trained physicist, and you've made this decision that you'd like to pursue a career in software. Now, how do you get your first job now with those credentials?
Well, I guess for me, I just got lucky. I applied a number of places. Back then, computer science was not very well established in England as a university course. There were places, but not that many. So for people in the software business, they would typically have come with a different background in terms of their college education. So it was not unusual.
So you weren't so much competing with other candidates who had trained formally, or so many?
That's right. And of course, it was an expanding business. So, you know, everyone's looking for people who can code and who have, you know, smarts.
So where was your first job then out of college?
That was in London. I worked for Burroughs. That was kind of interesting because I saw this ad in the paper and I thought, oh, I remember reading about Burroughs. They have some interesting machines, you know, these Algol machine mainframes that they had and other such goodies. So I thought, let me go find out. And it turned out to be a rather dull place, building teller machines.
Teller machines as in cash machines?
Yes.
Yes.
Right. These things weighed like 2.5 tons and had 64K memory in them and stuff like that. But the manager of the software department there was a very motivating guy. He persuaded me that there was interesting stuff to do even in that kind of environment, which turned out to be true to a degree. That was Jim Harris. He later ended up as a VP of OEM at Microsoft, which entails how I ended up getting here. But he became a good personal friend as well as my boss.
And he was the one who decided to take a chance on this physicist in
Yes.
the software job.
Yes.
And what was your project specifically? So you said you were working on cash machines or teller machines, and what was your specific role on that project?
My main role in the end was, in the first job, was taking responsibility for the compiler that we had. And essentially I ended up rewriting the thing because it was so slow. And, you know, we did the usual thing of attacking the hotspots first. You know, what's taking the most time? How do I speed that up? But at the end of the day, it entailed a rewrite from one implementation language to a different one that had better performance.
And so eventually, though, this was, I guess, around 1980, you took up some interest in graphics programming again. Is that? Yes.
When I'd been doing my graduate work, I'd done a certain amount of computer graphics work, and enjoyed doing that. When the time came to move on from Burroughs, I was looking around for places that would be doing particularly interactive graphics, not just, you know, output-only graph plotter type stuff. And there was a project running in the Rutherford lab, which is where I went. It was actually being run by the guy who'd been running the computer system at the physics lab where I'd done my graduate work, so there was a personal contact there. And I responded to an ad, I think, and got in touch with him directly and said, you know, what kind of work do you have going? This is what I'm interested in. And he said, come on board.
I'm assuming named after Ernest Rutherford,
yes.
the high-energy physicist? And,
yes.
And you're a high-energy physicist yourself, yet the work you were doing there was not...
Was not physics, no.
Was not directly related to that.
Not at all, in fact.
And so this was... It kind of helps set the context for me here. In 1980, there was no SGI, there was no Sun, and yet you were doing interactive graphics workstations work.
Yes. So just for the context, the project there was setting up originally a network of mini computers that were all connected around the country so that they could do software distribution and support and whatever. And these mini computers were intended specifically for use with attached graphics terminals for doing interactive engineering analysis and such things. And the people running this project realized that, you know, time is coming when we're getting more and more interactivity in the workstations. So in fact, you take the computer and put it inside the graphics terminal instead of having it stretched over a thin wire and going slow. And so they had arranged to try to get supplies of this new machine called the PERC. It was made by a company called Three Rivers. And this was basically a commercialized form of the Alto computer that Xerox PARC had produced. And so there you're getting very high-speed interactivity, interactive graphics, high-resolution screens. You can just do a lot more and a lot better.
Now, you said Three Rivers Computers. Now, Three Rivers is also used to be the name of the football stadium in Pittsburgh near Carnegie Mellon University. Is that a coincidence there? Or these?
They were based in Pittsburgh.
All right.
Yeah, they later renamed themselves PERC Systems Corporation and then vanished.
And this, as has happened to so many hardware companies.
Yes.
But these systems, this was based on Mach, as I understand it, right? Which was one of Rick Rashid's early projects. Yeah.
So the work I was doing was related to that. The computers came with some really lame single task operating system, and everybody knew that for real work you needed a real operating system. So the intention was to get some flavor of Unix implemented on this computer. And I was involved in a project to try to take the Mach kernel from Carnegie Mellon, which was being implemented on that system, and then put a Unix emulation layer on the top of that. And that was the project that I was working on for, well, I don't know, best part of a year, I would think. And we finally had to just kill it. It was not going to work.
So at this time, you were working in Rutherford Lab in England, and the rest of the Mach team, though, was still at Carnegie Mellon here in Pittsburgh.
Yeah, that was part of the problem. I mean, we used to get, some build of their Mach kernel would get shipped over, and they didn't really have a formal release process. I mean, they're a university doing it for their own purposes, so you get potluck of what you get there. And we would get builds where, if you compiled the sources from scratch, it didn't work, but if you ran the binaries they gave you, it did work. And it's like, what's that about? And when it came time to say, well, we sort of got it working, but it really is kind of slow, and you start trying to do performance measurement, say, where's all the time going? And, you find the variability in timing is 10 times larger than the actual number you're trying to measure. So you can't even measure the damn thing. And there were various humorous things that happened in that period. I remember calling up Rick Reshid saying, what's the cheapest way to get timing in measurements? So he tells me that, well, there's this register in the machine that has the number of clock cycles since whatever. And so I said, oh, how do I read that? And he said, well, there's this machine instruction that will let you read and write any register.
Write to any register?
Yes, that was exactly my reaction.
Because in today's time, there's so much work, for instance, in Vista, to make sure that you have as little access as possible to various machine registers.
Indeed. So let me explain a little more. This was a microcoded machine, so this, at the micro instruction level, there's some 200 registers, and these are used for things like stack pointer and program counter and temporary, computation accumulators and things like that. And he's put this instruction in that lets a higher sort of program written in a higher level language read and write any one of those registers quite freely. So when he tells me this, I just went quiet as I was thinking through the ramifications of this. Here I am with a buggy kernel, a buggy compiler trying to write software, and this thing can destabilize the machine at any time. So while I'm pondering this, Rick Rashid's on the other end of the phone 5,000 miles away, and he just says, think of the power.
Hopefully the power for good.
So I said, this is a privileged instruction, right? And he said, oh, yes, but by the way, privilege is on by default. So the first thing I did was go turn off privilege and rerun everything, make sure it ran the same way, which it did, so that wasn't the cause of my problems. But that was just one of those little episodes that was entertaining to me.
Certainly one of these things you assume it's done a certain way and then discover.
Well, just surprises, let's put it that way. Exactly. Things you might not expect to find that are in fact there.
When you joined Microsoft in 1988, certainly Microsoft was not its current size. Or had you even heard of Microsoft? Were you familiar?
I had certainly heard of Microsoft. I'd even had some encounter with Microsoft Windows. We'd run a workshop on window management systems, and there was a Microsoft rep there talking about Microsoft Windows, of course. So I'd had some encounter with that. I was aware of DOS. I was aware of the languages products. And I have to say that, my first thought was, is Microsoft the kind of place I want to go? Is that the kind of product I want to work on? I don't know. But I was contacted by Paul Moritz, who was running the networking group at the time at Microsoft. And he said, the applications division is looking for a person to do a particular job. Might you be interested? His timing was perfect. I had just had it up to here with government stuff and all the attempts to get research funding, which was just a miserable experience. So I was ready to move on, and so I said, well, try me out. And, we did a phone screen, and then they flew me out. And
so Paul Moritz did your phone screen?
No, Nathan Mervold actually did that. I just said, Paul, that, tell him I'm willing to listen. And so Nathan called me one evening, gave me a phone screen. And most of his time was spent actually selling me on the position.
And when you arrived here, you referred to the applications division. Now, of course, we refer to it sort of collectively as Office. But I guess in 1988, did we even call it Office yet?
No, we didn't. It wasn't called Office. And in fact, it really was that was the beginning of forming it as a real applications division and giving it a manager that was Mike Maples was brought in to do that, and really sort of growing that business substantially. There had been a Word group and an Excel group and a few other application groups, as well, of course, as the older DOS applications. But they sort of formalizing the division and the management structure and the organization of it. But it was just applications back then.
And they were just sort of separate teams working on separate projects?
Yes, yes.
So what was your first project when you did arrive?
Well, the job they asked me to do was to sort of figure out how to do integration across these applications, how to get code sharing, how to get data sharing, why do I have tables in Word and why do I have tables in Excel, that kind of issues. How do we make these things work together rather than be separate silos? And that was kind of challenging because, of course, each of the application groups considered themselves as their mentality was like an independent company, right? I'm in the Word company and I'm trying to sell Word, and if I'm going to do any integration with spreadsheets, I want to integrate with the one that's dominant out there, and that's 1, 2, 3. Excel, who's that? So it was really challenging to try to get these groups to sort of focus on getting their products to talk to each other rather than each other's competitors.
So throughout much of your career, though, you've been working to help make developers more productive. And some people have told us that you don't write a great deal of code yourself. We talked to Craig Wittenberg, who worked for you as a development manager for a while, and here's what he had to say.
Well, it's true that Tony does not write a lot of code. I think that's by design. In fact, we've had some conversations in our group about what the role of architects should be. And it was very clear in his mind that the developers were the ones who would produce the code, the products, the tangible results, and the architects had a different role. And he is very capable of coding and has discussed many times his work in the past in the physics labs in England and other places. And in fact, he's also doing some samples right now. But it was a very concerted, specific choice that he made to not code. Clemens doesn't code either. They review a lot of code and they discuss very detailed things, but their output, their results, the products that they create are not code.
So is that true?
Yes, for most of my time here, I have not written code in production. I did write half a line of code that was in the OLE DLL.
Half a line of code?
Half a line of code. It was just quicker to type it than explain to the developer what the code should do.
So what, you left it to him to type the semicolon? How do you type half a line of code?
Well, it's a bug fix, right? So you select half of it and you type something over it and you're done.
I see.
So yes, I do have like 3 instructions that are in the product there. Okay. I did make a conscious decision. I mean, when I was hired, they gave me this title, software architect, which I think in part is just a feel-good thing, or it was then. I decided, no, I'm going to take this seriously. I'm going to try to be an architect. And if I'm thinking about how do I get Word and Excel and PowerPoint and these applications to talk to each other, those teams are have very strong ownership of their code. And I thought they're not going to take very kindly to me going in and saying, here's code, put it in your product. So I very much took the approach of saying I'm going to work through those teams to achieve the goals. And later when we got the OLE team started, when I had a team that was responsible for producing code, I kind of took the same approach of saying, developers need to feel ownership of their code. And they will be more productive that way. They will be more willing to work with me when they own the code. If they feel that I'm telling them what to do or I'm giving them code that they then have to use, the relationship isn't quite as good. The working relationship.
I think it was Crispin Goswell made the remark about you. You manage subliminally, I think was his comment.
That one I hadn't heard, okay.
But certainly we've heard several people who back up that, as you're saying, that keep the developers feeling that they own the code and yet provide guidance along the way.
Yeah, and it's been important all along because, I would write specs about, You know, here's the interface, here's what the definition is, here's what the code should do in prose. And the developer would come back and say, no, that really is an inconvenient way to express it. And if you change the interface this way, it's so much easier to implement on this side and on the calling side. So why not do that? And the answer is, yeah, you're absolutely right. You know, I can't get the perfect answer just by thinking. So it's very much an interactive process, and it's better to do that with someone who has a strong sense of ownership. And, you know, for me, it's been effective. Now, I have more recently been writing code, and I remarked earlier, I'm enjoying it just as much, you know, when you do something and you're trying an idea out and you run it and it works and it's like, yes, you get that feeling.
You get the tangible result right away.
You see the result, but more to the point is it's like, yes, I knew that was the right thing to do, you know, and it's this thing that you get inside. That feeling never goes away. You know, I haven't had it for 20 years, but it never goes away.
Well, moving back those years then, this was shortly after you arrived at Microsoft, was when Microsoft acquired Forte, the company that makes PowerPoint. And as I understand it, PowerPoint wanted to add a new feature to draw graphs inside PowerPoint. Yes. And how did you get involved in that, though?
So I think PowerPoint was acquired actually shortly before I came. In part, I think it was Bill who said, you know, the PowerPoint team wanted to do a charting system to put in their product, so that people could do, you know, business presentations with here are the sales figures, projections for next year, and all that, lies. And Bill basically said, no way am I going to fund you to go build a charting package when I have Excel, which has charts. So you need to figure out how to use Excel to get your charts in there. And basically he asked me to go work with these guys to help figure out how to do that. And that was one of the challenging experiences. So these two teams had looked at each other's code and mutually said, I'm not going anywhere near that code.
Because certainly naively you would look at this and say, well, there's this piece of code here and we all work for the same company now and we'll just use your code. What was wrong with that?
So their styles were totally different. Their cultures were completely different. Just everything was different. And so you had these two kind of mutually hostile organizations that were supposed to cooperate. And I got involved helping to write a clear spec of how you would send messages between these two things to say to Excel, please make this chart for me and get the picture back and then go put it in the PowerPoint presentation and all that stuff. And I was working with mostly with one of the PowerPoint developers who was writing some of that spec, and I worked with him and generalized it and said, you know, this works not just for charts and not just for PowerPoint. And, you know, that was what led to Ole version 1, which was you can take something out of some app and visualize it in the context of another app.
One question, though, that surely everyone must have asked you, and I'll ask you one more time. Now, why invent yet another way of objects communicating with each other? You know, there was Smalltalk, there was C++. Why did we need this other method?
Well, we needed something that an existing application like Word could go implement their part of this in their existing code base, which isn't written in Smalltalk or any of those things. And they're not going to rewrite it in any of those languages. Performance is an issue. Reliability is an issue in the sense that, you know, if you're going to hook up to some objects and you're going to call methods on it, you have to know at the time you connect to it that it will, in fact, respond to those methods. You don't want to start working against it and then have it say, sorry, I don't know what you're talking about. This is the Smalltalk message not understood problem, right? And systems like Smalltalk that have this characteristic, if you don't have a perfect application, then what happens is then at runtime, some dialog pops up saying, message not understood, here's a traceback window. Well, I don't want to show that to a person. I don't want to show that to a non-programmer. That stuff's great for developers. But for someone who's trying to write a document, that would be a disaster.
Certainly.
So there are all these characteristics of these other object systems that just are inappropriate. And so I basically just had to say, well, I'm going to just define what the set of methods is on these objects and, you know, nail down exactly what the parameters are and all that stuff. And when I connect to the object, I'll do a quick check. Do you claim to support this set of methods? And if you do, then I'll assume you do. And it's the other guy's responsibility to test his code and make sure it does.
And hopefully he did.
And hopefully he did, but as we subsequently discovered, that's not always the case.
Well, when along the way did you start to see the bigger picture of this? I mean, you started out doing this, as you say, just for a few applications inside Office. And when did it really hit you? What a big thing you were starting here.
It was really a question of seeing how you could generalize the approach and say, there's more kinds of integration you want to do than just pasting a picture into a document.
Certainly.
Okay, so you want to be able to do, what I would call functional integration, so that there's a calculation engine over in Excel. Maybe I can call upon it and ask it to calculate something for me. So, you start looking at the generalization of the capabilities beyond the original. So even at the beginning, I had designed in the basic approach that said, back then I called them protocols, but we later called them interfaces. And we said there's not just one interface. In principle, there are many. Mm-hmm. And so this initial connect time check of saying, do you support this protocol, is picking one out of the potential many and saying, do you have this one? And if you do, then we can talk. But even back then, I'd said, this can generalize and you can have more ways. Because I wanted the richness of integration to be something that could increase with time. That as we do more work, we can get more and more rich integration. And so you might, for example, want to apply word styles to elements in a drawing being supplied in a drawing package or whatever. Mm-hmm. And if you're going to have that room to grow, you have to have a way to negotiate.
All right.
And so that had been built in from the start. When it came time to do OLE 2, we were going to add lots and lots of new stuff, in-place editing, drag, drop. So that means a whole new set of interfaces to handle all that stuff. And we decided to bite the bullet and make a much more formalized model of what is an object, what does it mean to have interfaces, what does it mean to negotiate over them. And that's COM. Mm-hmm. That became COM.
Now, one teaser in there. You said that interfaces were once going to be called protocols. That's news to me. What led to the change? Why?
So we had one of these horrible meetings where you sit and before you ship your product, you go over all the names that are going to be in that product and people are going to see, and you spend hours arguing which is the right name. Protocol became interface for really two reasons. One was the NT team had a networking group and they thought they knew what protocols were and that they owned that word.
Okay.
The other reason was that it really, what we subsequently called interfaces really were just one side of the story. It's how does A call B? It doesn't really capture all of the ramifications as well. What happens if B turns around and calls A again? If you can pass a reference back and forth, you can do that. And so I thought, well, it's kind of convenient to reserve the word protocol for the sort of the larger picture and say an interface is just part of a protocol. So I thought I'll have that one in my back pocket that I can use later.
So you're planning for the future by reserving the word protocol for future use.
Yes, kind of.
Which we've still not yet, but.
No, I mean we tend to talk now more in terms of things like contracts as being sort of trying to capture the essence of what is the defined relationship between these communicating parties. And, contracts is actually probably a better word than protocol.
Is there a Tony method for selling people on their ideas? And
I don't know that I have a method. I mean, I think for OLE 2, the thing that really established it was basically Bill said, you're going to do this. And then it was a matter of negotiating over the feature set.
Okay.
So you
had executive support.
There was executive support from Bill and from the VP at the time that said, yes, we're going to do this for the Office apps in this wave. That was about the time they were starting to call it Office. And so then the question is, well, how do you decide the feature set? And so we made a big long list and sent it around and said, check off which ones you like and which ones you don't like. And got the results back. And if you looked at the set that everybody liked, that was what OLE 1 did.
Okay.
And if you looked at the set that anybody liked, it was the list that we had generated. So you somehow have to draw a line on what you can actually afford to do. And then it's a resource trade-off. So a lot of things that we tried to put in the early specs just got cut, things like inheritance of properties between the container and the object, the style example. Other things did make it in, like the drag drop and the in-place editing and those sorts of things.
Well, you mentioned inheritance. That is certainly one of the things that differentiates COM from so many of the other object methods out there, such as, again, C++ or Smalltalk, where there is no inheritance in COM.
That's correct. So the property inheritance I was referring to was not really a class inheritance scheme. It was really about being able to acquire things like font and size information from your environment. And so it's more a communication between instances than classes. Inheritance was something I elected not to put in because inheritance is something it's a way to write frameworks that people can then just extend the framework and get magic code out. But I was trying to deal with applications that already existed and were not built with my framework because I didn't have one to give them. But even if I had one, their applications were not built that way. So how does it help? It just doesn't.
We have some video from one of the very first times that the public got to see COM in action. Let's take a look.
The scenario here, this is going to be the shortest demo I've ever done. The scenario here is on the left. I have an image of a document. Perhaps it's something I've received by fax. I'm previewing it. I can barely read it, and I'm sure you can't. But I can recognize that it's a document that I'm working on with a collaborator, and I need to do some edits to this before I send it back to him. Of course, this thing's stored as a bitmap in this fax management application. This is actually a word scan application, which is a beta copy or a pre-release that we're using for this demo. It's not quite shipping yet. Now, my preferred editor is Microsoft Word, so I'm going to want to edit this thing. The most natural thing for me to do is to say, gee, I'll take that thing and I'll drag it over and transfer it into Word. Now, what's happening here is that we're not creating an embedding with this fax in it. What's happening is that the Word is executing the OLE data transfer negotiation, which says, can you give me rich text? WordScan says, sure, I can give you rich text, and invokes its OCR process that you saw in the window where it was scanning down, recognizing the characters, turning it into formatted text here, which Word can now edit. Right? So this is an example of exploiting a piece of OLE, the drag-drop protocol, for something that isn't related to embeddings. It's related to stuff that is more appropriate in this particular example, which is data transfer and manipulating the data rather than simply embedding it. So one very small example. I told you it was a short demo. Thanks.
That really is one of the shortest demos that I think I've ever seen. Do you remember even giving that?
Yes, I remember it well.
So the short demo, I suppose, is consistent. We hear a lot from a lot of people that you're also very brief in your emails and in the specs and things that you write. I
generally try to be short, yes. I wrote a Think Week paper for Bill that ended up being like, I think, 3 pages. It took me about a week of thinking to be able to distill the content of that down to that length. And a lot of people have said it was a very readable paper and it made the point very clearly. So yes, I do consciously try to do that.
Now, there have always been these two related technologies. There's OLE and there's COM, and we tend to talk about them together. But what is really the relationship? Was sort of one invented to implement the other, or one as a test case for the other?
Well, sort of COM is the underlying model of what is an object, what is an interface, how do you instantiate and connect, and it's otherwise silent on what the objects can actually do. So then OLE is a suite of interface definitions and supporting helper code for a particular set of interfaces that deal with various forms of application integration. So, compound document storage, data transfer, clipboard drag-drop, rendering images of objects in a context, in-place editing, menu sharing, toolbar sharing, that sort of stuff. So there's a suite of interfaces for doing particular kinds of application integration layered on top of an underlying model of what an object is.
And did you have that from the beginning, sort of as you were developing COM? Did you also have OLE there to sort of serve as a test case?
Oh, absolutely. They were co-developed, yes. And we just tried to keep the layering very clear. We had this vision that the COM model itself could be used completely independent of OLE. And we actually packaged it in a separate DLL originally, so that in principle, you could just install that one DLL and forget the rest of OLE. Because, you know, there was a time when people cared about disk space, both in, you know, shipping floppy disks and on the hard drive and things, you know, so it potentially mattered.
So you had this team that was developing OLE that was working right alongside, and therefore they had a chance to find out anything they needed to know about COM.
Well, it was really one team, but we sort of just always tried to keep clear the distinction between what's in here and what's in there.
So that they did keep that separability.
Yes, and in fact, Craig Wittenberg was really instrumental in making sure that happened. He was the dev lead at that time, and he really took the lead on implementing the runtime support for COM and keeping it clean and clear of the other stuff. So yeah, he was very important in keeping that separation.
Well, Charlie Kindle was one of the people who understood COM really before a lot of other people did, and he was one of the first evangelists of COM. And we had a chance to talk to Charlie about your communication style.
Oh boy.
One of the things I learned from Tony real early on was his communication style. He was very effective at communicating his thoughts on paper, in writing, in email, or even verbally, without having to pound his fist on the table or scream and yell. Always very rational explanations for things based on his experience, based on technology, ideas, and I tried to learn and emulate that over time.
Is it true?
I think you have to ask other people. You know, I try to communicate clearly. How successful I am is something to judge by the results. I think I have heard various things at various times. There was one time at a PDC I'd been giving a presentation, and afterwards one of the attendees said to me that it was kind of interesting that at the beginning of my talk I sounded kind of American, and as I got into it more, my voice became more and more British. Someone else at the PDC said, "Oh, I love listening to you talk," and I said, "Why?" And she said, "You speak in complete sentences."
Perhaps there's a lesson in that to the rest of us.
Well, it makes you wonder.
Well, later you worked to try to get COM supported more natively by the operating system itself, as opposed to being just part of Office. It was something that all the applications could use because it was built right into Windows.
Yes. I mean, the OLE 1 support code got rolled into Windows 3.1 so that it was just there for everybody. We wanted to do the same thing with OLE 2, but of course at that time it was not Windows 3.1 anymore. It was the transition to 32-bit Windows, so it was Windows 95 and NT. And so after we actually delivered the first round of OLE and the Office apps, we actually moved most of the team into the NT team to go do that work of integrating it into Windows. And of course there were real challenges there because Windows 95 and NT, they were very different environments. I remember asking questions and not getting answers. You know, how can I have one code base that works in both and is effective and efficient?
And yet .NET in a way sort of grew from COM or COM Plus, as I understand it.
I don't think so. I mean, with COM and OLE, we'd always had the problem of there was no knowledge or understanding of this model in any of our tools. I mean, we did ultimately put support in the MFC framework to make it easier to build applications that used that stuff, but the tools didn't understand it. Debugging was difficult, you know, all this that kind of stuff. And when .NET was getting started, they said, well, you know, we really need to have. First of all, their focus was on developer productivity, not app integration, which is a very different focus. And they've done very well at it, but they came up with a different tooling story, which meant a different object model, and off they went. So they are, in fact, very different in many ways. The fact that there's some amount of interoperability between the two is reasonable, but it's not a very rich one. I don't think I would want to go and write an extension to Word in managed code, you know, to be an embedded object. I think that would be kind of hard. So it's really quite a different thing.
I understand you also got you've gotten some somewhat mixed feedback on the registry, which was partially invented really for Calm's benefit.
Yes.
You've even shown a slide where you express your true feelings about it.
Yes, I wrote that slide for a presentation to MSR, actually. One of the few times I've actually done a build on a PowerPoint slide. So a slide title comes up, a few words about the registry, and I sort of give a brief intro about, yes, let me tell you about the registry, and then I push the button and it says, sorry. I certainly wish we hadn't done that one. The registry was an interim stopgap measure to allow one app to say, here's an ID for a class of an object, where is the program that corresponds to this? So you need a place to go to answer that question. And the registry was the stopgap measure because, of course, we were going to have, remember the object-oriented framework of death, right? This was going to take care of all that.
Okay.
It was going to have a class manager and a type database and all those things, and it would just be magic. You just wouldn't have to worry about it. But we needed something to ship now, and hence the registry was born. And from there, it's all downhill. I started the ball rolling by putting more stuff in it than I should have done. I should have realized, no, this needs to be really minimal. And I allowed myself to get lazy and put more in there than should be there. And then OLE Automation came along and put in, 100 kilobytes of stuff up to do with pointers to type libraries, so that if you want to talk to Excel with OLE Automation, you can find all that, and that's all in the registry too. The Windows 95 team decided it would be cool to tell people to stop using any files and put everything in the registry instead. And it just sort of gets bigger and bigger and bigger and more complex without people kind of really realizing. I suddenly discovered one day that the registry is a critical component for the NT boot path. So your machine won't boot unless your registry is working. And
And yet it started with such humble beginnings.
It started with such humble beginnings.
Well, later on you had worked on trying to sort of rewrite a fair amount of Office, being more heavily based on COM, and that project eventually was canceled. What was the story there?
Well, my original goal was to enable Office apps to sort of start carving out pieces and like charting, for example, and putting COM interfaces around it and then letting other people use it directly if they wanted to. But the Office teams were never very interested in that. My goal was to enable this kind of code sharing and better extensibility and so on. The Office team didn't get very interested. We never really tried to embark on a big rewrite because the expense of that would be just too great. I had a small project where we said, as an experiment, let's take the Excel recalc engine and package it the way I just described. Extract it from Excel, make it standalone, put COM interfaces around it, and see if we can reuse it for something. And we sort of did the first step of saying, let's extract it from Excel and put some interfaces on it and prove that we can run it. And we did that. Step two was let's refactor it, clean it up, shrink it down to its minimum thing, get rid of all the junk that, when we extracted it from Excel, all of these tendrils of stuff came with it, and we'd want to cut those out. But before we embarked on that, we did some analysis of, what we'd got as a result of this, how long it had taken, how long it would take to go do that cleanup job. And basically concluded, no, for the cost of that, I could write one of these from scratch, and it would be just as, it would be cleaner. I wouldn't have any historical baggage to deal with, and it would just be cheaper to do that rather than try to extract and clean up what was in Excel.
So you spent the effort on just figuring out how much effort would it be to finish this, and eventually decide just not worth doing. Right,
and so my conclusion is that just wouldn't be worth anybody's time to do. We wrote up a paper on that experience, and among other things, I think that helped the Office team make some decisions about things like what's the best way to build a word viewer, or what's the best way to build a pocket word, and you might think, well, how do I, if I take Word and strip it down, do I get a pocket word? And they look at it and say, well, this data seems to indicate that would be a very expensive way to do that. And so it did help them to make certain decisions of that nature. And what it led me to do was say, well, given that we aren't going to start carving Office apps into components, if we're ever going to have any application components, we need to start building them.
Okay.
And so that's what led me to go to, in the end, to Rick Rashid and say, this is what I want to do. Can I come and do this in your advanced development division?
And by this point, Rick Rashid is heading Microsoft Research.
Yes.
He's left Carnegie Mellon years prior, and
yes.
we're getting more up to the present time. And you worked on what we now call the Connected Application Framework.
A forerunner of it, yes. We started a group, it was called ComApps. We were proposing to basically build a component framework rather than, the kind of .NET style of framework, so that we could build a sort of product line of new applications. And we thought of it as an advanced development activity, but there really was actually a substantive research element to it, I think. So we spent some years working on that, working on components and composition. Once you've got your components, how do you put them together to make an application? And culminating in, some demos to Bill of how you can build a real, fairly rich user interface in that style.
So you had this team, and you had a technical vision of your own, and somewhere along the way, you got merged in with the intentional programming team of Charles Simonyi. And he, of course, had a team and a vision. Now, how do you get these things reconciled, his vision and yours?
That was interesting. So let me back up and set some background. We had demoed our work to Bill, and basically said, so how, if at all, do we move this forward? And he asked us to sort of hang on for a month or two while he figured out what to do here. And meanwhile, Charles Simonyi had been taking some ideas from his intentional programming team and touting them around to people, saying, let's apply these ideas not to code, which is what IP was about, but to data. Because XML was all the rage, XML is tree structured, Charles's IP was all about transformations on trees. My team's work was about declarative construction of applications, and Bill says, so if I want applications that process trees, because the world is all going XML, can't I take that and put them together? So he asked us to merge and investigate what we could do. So we spent some time talking about what the result might be. Having disagreements about things that I still don't really understand. I would draw a picture of saying, here's this and here's this and here's this, and Charles would look at it and say, I don't get it. What's that all about? That's meaningless. And
was this your first time working with Charles?
Yes, it was. And I would point out, well, here's this piece of data that does this, and here's this other piece that does this. And he says, but they're all trees, right? And I said, yes, they're all trees. This was important to him. So I said, yes, they're all trees. And as for him, he said, well, that's all you need to say. Nothing else is important except that they're all trees. And so I couldn't understand, without saying more than it's all trees, how to actually build something. And I took it as being...
Once you understand it's a tree, there's nothing to build anymore.
Well, so I took it to be that, my contribution to the effort was to make sure that we produce something that works, that delivers, rather than ideas, concepts, or whatever. So that was sort of a lot of debate and back and forth, and sometimes it was kind of quite unpleasant. But we did deliver on that. We are delivering a smallish application in Office 12, which is built that way.
And what is this application?
It's a calendar printing application. The code name was XCal. The product name is something disgusting. Calendar printing assistant for Microsoft Office Outlook 2007.
That was very good. Well rehearsed. So that though has come from this. That is the outcome of the Connected Application Frameworks.
Well, it's like the first deliverable that embodies what we called then the XML application framework, which we renamed to be Connected Application Framework when we decided to move it over to the Connected Systems division, because you have to get with the program. But yes, that is the first deliverable that's built on that technology and that approach. And it does embody the trees and transformations that were part of the IP. It does embody the declarative construction and composition of applications. And I'm very pleased about it.
So do you feel like what you learned building COM helped you build this, or do you almost wish you had skipped to this in the first place?
I'm quite sure that the COM experience was very important and valuable. I mean, when we were trying to do the component and composition thing, we were learning lots of stuff beyond what we learned in COM. But the COM side of it stands up very well in my mind. I mean, modulo the tool experience and all the problems that people have with it. Architecturally, I think it stands up just fine. What we learned was in other areas about debuggability, about the fact that none of our tools really support the idea of components in the sense that we meant it.
And when you say tools, you're referring to compiler, debugger type
compilers,
tools?
Compilers, debuggers, linkers. So there's a tool called CVPack that if you're merging separately compiled binaries together, it compresses down the debug information that's duplicated otherwise across these different modules. And if you don't compress it down, you just have this huge bloat problem. And if you do compress it down, you use CVPack, but it only works on, it won't merge DLLs together, for example. It only works on object files, I think. He wrote CVPack.
This would be Rico Mariani?
Yes.
Okay.
We called him up and said, well, we have a slightly different twist on this problem, and here's what we need to do. And his answer was, if you can possibly find a way to solve your problem without doing that, do so. Okay. So it's just one more way that components are not sort of well supported by any of our tools. And languages, for that matter. The language definitions don't really lend themselves to this. The point being that when you've got a component, you've got an isolation boundary within which a name means a thing. Mm-hmm. A variable, a function, whatever. A name means thing. And the same name in this component over here might mean something completely different.
Certainly.
And our debuggers don't understand that. Right? They don't understand that this type name in this module is different from this exact same type name in this module.
So in effect, each component is kind of an implied namespace.
Yeah.
But
right. So .NET addresses a lot of those kinds of issues in their world, but then they have other things that they don't deal with in terms of isolation. So there's just been a lot of learning to do there, and certainly there's no way that I could say, if I'd just pointed myself in the right direction, I could have got to where we are today 10 years ago or so. There's no way I could say that, because I wouldn't have known what to do. There's just a long way to go and a lot to learn.
Moving on to some fun things, Tony. What do you do in your spare time?
I'm a crossword puzzle junkie.
Really?
Yeah, the British style of crossword puzzles, what they call cryptic. It's a mental exercise. I really enjoy it.
How does a British-style crossword puzzle differ from an American style?
What they call a cryptic clue is there's a section of the clue which is the definition of the word, and there's a section which is how to build up that word piecemeal out of small parts that are defined in that cryptic section of the clue. So it's not just find a word that means whatever the definition is, because you don't even know which part of the clue is the definition and which one is the cryptic part. So working that out is part of the fun. And the harder ones that I like are where you don't even know where it goes in the diagram. You just you know what letter it begins with, and eventually you're going to have to fit them all in to make them match up. So the process is one of acquiring information slowly over the course of solving the puzzle, which is a feature that I like about it.
I understand you're also building a new house?
Yes, we're about halfway through that.
Any particular features of the house you'd like to talk about?
Yeah, sure. On the property, there was an existing sort of half-buried boathouse down the hill. And when I looked at the plans and saw the house with the basement and the boathouse and the way they lined up, I said, I want a tunnel. I want to put a tunnel from the basement of the house through to the boathouse.
Why?
I just wanted it, and people say, "What's it for?" And I say, "I don't know, but it's cool." And everybody said, "Yeah, it is. It's cool. What's it for?" Again, and it's just cool. my original idea was a kind of a dungeon aesthetic. You know, you walk in, there's stones and cobwebs and dripping water, and, you know, you can lead the guests down there and say, let me show you what I have. But we ended up going with a more industrial kind of style. So there's an 8-foot diameter concrete pipe that runs 50 feet from the house to the boathouse, and it bends slightly in the middle, so you can't quite see what's down at the other end when you start out. It's a lot of fun.
How does designing a house compare with, say, designing software?
I think there are parallels. I think designing a house has typically a lot more of the details that in software we would leave to developers, but are considered by the architects, because, you know, their aesthetic says, I don't want this vent coming out of the roof because I don't want to be looking at this lump when I should see a nice horizontal line. So their sort of overriding concern with aesthetics has quite means they pay a lot more attention to a lot of the things that you might consider detail. I think there is a lot more aesthetics in it, a lot more sort of sense of what will it feel like, what will it look like, how will you enjoy it.
And you're saying there's more of that in the house than in the software?
I think so. I mean, I think we don't really pay enough, as much attention to those sorts of things as we could in software. We do spend a lot of time on usability and on visual design and so on, but I think we should do more. I think we'd be better off if we did do more.
Are both jobs equally hard to keep on a schedule?
Well, so the architects, you can't keep an architect on a schedule. You can only tell him to stop, you know. And that's true for both software and building architects. The building process itself is challenging, but they seem to have a bit more flexibility of how to accommodate external factors that change out from under them. We had a contractor who was going to build some concrete columns, decide that he couldn't do it. He didn't have enough capacity, and he couldn't do it at that price anyway, so he skipped. And we had to find a new one, which meant, well, what's going to hold the floor up while we wait for those columns? So they have to work around things like that. But they do seem to be quite effective at it. I think I've found a good contractor, which makes me feel a lot better. Overall schedule, we don't really know too accurately when they're supposed to be done. My wife and I decided that it'll be done when it'll be done. And so we'll make sure that we aren't tied to a particular date, because, you know, you don't want to be making bad decisions just to make the date. So we said, okay, it'll be ready when it's ready. In practical terms, we think it's going to be somewhat more than a year from now before we move in.
Good. Tony, we have a few questions that we ask all of our guests on this show, and the first one is, what advice do you have for someone in this field?
I would say choose work that's challenging and interesting, because it will keep your attention and it will help you learn, but also save some time for playing with ideas. That's been important to me.
How would you describe your work to someone who's not technical?
I would use the building architecture metaphor of saying, you know, I do for software what an architect does for buildings, which is figure out what it's for, how it'll be used, how it needs to be constructed, put it all together, make sure it meets all the requirements.
So in life, what would you compare to developing software?
There are ways that software is unique, unlike other activities. There's a human creativity element, but we also do it in large teams, which we don't do in other areas that entail human creativity. You know, a composer works alone by and large. You don't have, you know, 1,000-person teams of songwriters. It's just different. I don't think there's any direct comparison with something else.
You know you're a computer nerd when?
Well, today's answer is when you send email to your wife who's sitting next to you on the couch. For me, hey, I do it every day. Come on. For me, it was, I was working late one night in the lab in Oxford and, pounding away on the keyboard and doing my computer graphics and having that, yes, it works experience. And suddenly I hear this noise and I look around and there's a guy in a white coat emptying the trash cans. And it's 6 a.m. and this guy's starting work, It's when you get into that flow of, everything's going and you just lose track of what the world is out there. The other thing that I had there was I was working with one of these Tektronix storage tubes. I don't know if you remember those graphics terminals, bright green on dark green screen. And it was brand new, so it was very bright, this screen. And I sort of sat back when I heard this noise, and I got the color subtraction thing, been staring at green for hours, which leaves red. But the wall was blue, so I'm looking at this hideous puce wall. That's my answer.
So we'd like you to draw your favorite data structure and explain it to us.
I was thinking of being glib and just saying, cons, because you can build everything else out of that. But so
the Lisp concept, you mean?
Yes. But actually, no, I would say, the binary tree's got to be the most versatile structure, right? So you have, some value and pointers to other nodes. And it has all sorts of nice properties that you can build these things arbitrarily. You keep it sorted so that you can traverse it in, whatever order you want. You can add something in logarithmic time. You can do clever things like splay tree variations. And if you need to, you can walk over it and make a linear array out of it cheaply. It's just a very versatile and simple structure.
So if you could sign your name to that, please.
You going to hang it on the wall out here?
You can hold that up for everyone to see.
You are now deeply informed.
We have time to take some questions from the audience that we have here today.
Yeah, Tony, I'm curious. 18 years with any company is a long time, and in this industry it's phenomenally long. What keeps you excited and interested enough to keep coming back, especially when you've got that house to go build and those other things to do?
I feel like I've been working on really the same problem for 18 years or longer. I still believe in what I'm trying to do. I still believe we can do it. I still believe we can get the value out of it. And I want to make it happen. And, recently I've started doing some prototyping on something that I think will be an immense empowering feature for end users. And if I can deliver that, I really will feel I've achieved what I set out to achieve.
Thank you, Tony, from the Technical Community Network, for being our guest today. And thanks to those of you in the audience for coming.